This is KVS Naidu, lecturer in mathematics, Miriam College, Amalapuram. In previous class, we learned accuracy of numbers and types of errors. In this session, I would like to explain general error formula. General error formula. Very, very important. We derive a general error formula. A general formula for the error committed in using a functional relation. Let u is equal to f of x1, x2 and so on, xn be a function of several variables, x1, x2 and so on, xn. Be a function of several variables x1, x2 and so on, xn. If delta x1 comma delta x2 comma delta xn be the corresponding errors in x1, x2 and so on, xn respectively, then the error delta u in u is given by u plus delta u is equal to f of x1 plus delta x1, x2 plus delta x2 and so on, xn plus delta xn. Expanding the right hand side, u plus delta u is equal to f of x1 plus delta x1, x2 plus delta x2 plus and so on, xn plus delta xn. So let u is equal to f of x1 comma x2 comma xn be a function of several variables. Delta x1, delta x2 are the errors corresponding to the variables x1, x2 and so on. The error in u is equal to delta u is equal to f of x1 plus delta x1, x2 plus delta x2 plus xn plus delta xn. Expanding the right hand side, by Taylor series, we get u plus delta u is equal to f of x1, x2 and so on, xn plus dou f by dou x1 delta x1, dou f2 dou x2 delta x2 plus and so on, dou f by dou xn delta xn plus terms involving delta xi whole square, terms involving delta xi whole square, This is the expanding the right hand side Taylor series. U plus delta u is equal to f of x1, x2 and so on, xn. Dou f by dou x1 delta x1 plus dou f by dou x2 delta x2 plus dou f by dou x1 delta x1 plus terms involve delta x whole square. U plus delta u is equal to f of x1, x2, xn is equal to u. మనం u అనుకున్నాం కాబట్టి u plus dou f1 by dou x1 delta x1 dou f2 by dou x2 delta x2 plus and so on, dou f2 by dou xn delta xn plus terms involving delta xi whole square, The errors The errors the errors delta x1, delta x2 and so on delta xn. Delta x1, delta x2 and so on delta xn are very small. Are very small. The errors delta x1, delta x2 and so on delta xn are very small. Neglecting the squares and higher powers of delta xi. Neglecting the squares and higher powers. The squares and higher powers of delta xi we get. Neglecting the squares and higher powers of delta xi we get u plus delta u is equal to u plus dou f1 by dou x1 delta x1 dou f2 by dou x2 delta x2 plus dou f2 by plus and so on dou f2 dou xn delta xn and neglecting the powers higher powers delta xi whole square. So u cancel, therefore delta u is equal to dou f by dou x1 delta x1 plus dou f by dou x2 delta x2 plus and so on dou f by dou xn delta xn. This is the delta u. Now the relative error in u. Now the relative error in u is Vr is equal to delta u by u is equal to dou f by dou x1 delta x1 by u plus dou f by dou x2 delta x2 by u plus and so on dou f by dou xn delta xn by u delta xn by u. This is the relative error. Vr is equal to delta u by u is equal to dou f by dou x1 delta x1 by u plus dou f by dou x2 delta x2 by u plus dou f by dou xn delta xn by u. This is called general error formula. This is called general error formula. Very important. F is equal to x1 x2 and so on, u is equal to f of x1 x2 x2 and so on. Taylor's expand to the right hand side. Taylor series f of x1 x2 and so on xn x1 plus x2 plus dou f1 by dou x1 delta x1 plus dou f2 by dou x2 delta x2 plus dou f by dou xn delta xn plus terms involving higher powers. The errors delta x1 delta x2 delta xn are very small, so neglecting the squares and higher powers of delta xi we get u plus delta u is equal to u cancel, therefore delta u is equal to dou f by delta x dou x1 delta x1 dou f by dou x2 delta x2 plus dou f by dou xn delta xn. The relative error delta u by u dou f by dou x1 delta x1 plus by u delta x2 by u delta xn by u. This is called general error formula. General error formula problems. First problem, important 10 mark problems. If r is equal to, if first problem, if r is equal to 4 x square y cube z power 4 and errors in x y z b 0.001, compute the relative maximum error in R when x is equal to y is equal to z is equal to 1. X is equal to y is equal to z is equal to 1. Errors in x, y, z be 0.001. Given solution. Given r is equal to 4x square y cube by z power 4. Partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z. So dou r by dou x. Constant 4y cube z power 4 x square 2x. So 8 x y cube by z power 4. Next dou r by dou y. Constant 4x square by z power 4 y cube 3y square 12x square y square by z power 4. Next dou r by dou z is the constant 4x square y cube z power 4 minus 4z cube minus 4 power z power 5 minus 4 z power 5. That implies 4 to the 16x square y cube by z power 5. X to the power of minus 4. Z power minus 4. Minus 4 into z to the minus 1 minus 1. So 4 z power minus 5. So 4 by z power 5. Partial derivative with respect to x. Find dou r by dou x, dou r by dou y, and dou r by dou z. By general error formula, delta r is equal to dou r by dou x into delta x, dou r by dou x into delta x, dou r by dou y into delta y, dou r by dou z into delta z. By general error formula, dou r by absolute maximum error. First find absolute maximum error. Absolute values, only positive values. So absolute maximum error EA is equal to EA maximum is equal to modulus of dou r by dou x delta x plus dou r by dou y delta y plus dou r by dou z delta z. Dou r by dou y delta y, dou r by dou z delta y, dou r by dou z delta z. X is equal to y is equal to z 1 and errors in delta x delta y delta z is equal to 0.001. Absolute maximum error is equal to absolute maximum error is equal to absolute maximum error is equal to dou r by dou x. So x value, y value, z value 1. Dou r by dou x అంటే 8 into 1 1 cube by 1 power 4 into 0.001. 8 value plus కాబట్టి plus next 12 into 1 square plus 1 square 1 power 4 into 0.001 into 0.001 plus minus 16x 1 square plus 1 whole cube 1 power 5 into 0.001. Absolute value negative is plus. So is find VA maximum relative error absolute error is equal to 8 into 0.001. To find the scientific calculator, 8 into 0.001 is equal to 0.008 plus 12 into 0.001 0.012 plus 16 into 0.001 0.016. Adding plus 0.012 plus 0.008 is equal to 0.036. This is the absolute error maximum, A maximum. Relative maximum error, relative maximum error is equal to EA maximum by R value, X value 1, Y value 1, Z value 1. So EA maximum 0.036 by 4, 0.036 by 4. This implies answer is 0.009. Answer is 0.009. This is the first problem. By general error formula, delta R is equal to R by dou X, delta X dou R by dou Y, delta Y dou R by dou Z, delta Z. Absolute maximum error, X is equal to Y is equal to Z is equal to 1, delta X, delta Y, delta Z is equal to 0.001. Absolute maximum error, take a positive values only. So it's simplify the scientific calculator. 0.008 plus 0.0012 0.0016 plus 0.0036. Relative maximum error A maximum by R 0.036 by 4 0.009. This is first problem. Next, second problem. Second problem. Find the relative maximum error. Find the relative maximum error in U is equal to 5x whole square by z cube with delta x is equal to delta y is equal to delta z is equal to 0.001 and x is equal to y is equal to 1. U is equal to 5x whole square by z cube with delta x, delta y, delta z is equal to 0.001 and x, y, z is equal to 1. Solution given u is equal to 5x whole square by z cube. Find dou u by dou x with respect to 5y square by z cube x cube 1, so 5y square by z cube. Next, dou u by dou y 5x by z cube y square 2y 10xy by z cube. Next, dou u by dou z 5y square 5 xy square is constant minus 3 z power 4, that implies minus 15 xy square by z power 4. This is the dou u by dou x, dou u by dou y and dou u by dou x. By general error formula, dou u is delta u is equal to dou u by dou x delta x, dou u by dou y delta y, dou u by dou z delta z. Absolute maximum error, is equal to modulus dou u by dou x into delta x plus dou u by dou y into delta y plus dou u by dou z into delta z. X is equal to y is equal to z is equal to 1 and delta x, delta y, delta z is equal to 0.001. Absolute maximum error EA maximum is equal to dou u by dou x 5 into 1 square by 1 cube into 0.001 plus dou u by dou y 10 1 1 by 1 cube into 0.001 plus minus 15 1 1 square 1 power 4 into 0.001. Minus value take positive values using this scientific calculator. 5 into 0.001 5 into 0.001 plus 10 into 0.001 plus 15 into 0.001. 0.005 10 into 0.001 plus 0.01 15 into 0.001 0.015 plus 0.005 plus 0.01 is equal to 0.03 is equal to 0.03. Relative maximum error is equal to 0. Absolute maximum error 0.003. Therefore, relative maximum error is equal to EA maximum by U. U value 5 0.03 by 5 0.03 by 5 is equal to 0.006 0.006 is equal to 0.006. This is the second problem. Given u is equal to 5xy square by z cube, dou u by dou x, 5y square z cube, x value 1, 5y square by z cube. Next, dou u by dou y, 5x z cube by 2y, 10xy by z cube, dou u by dou z, 5xy square by minus 3z, z power 4, minus 5x whole square by z power 4. By general level formula, absolute maximum error x is equal to y is equal to 1 and z is equal to 1 and 0.005 and 0.0015 and 0.005, 0.001 and 0.015 and 0.03. Relative maximum error A by maximum by U 0.03 by 5 is equal to 0.006. This is the problem. I will continue the next class. Okay. Thank you.